welcome. Today we will talk about the scientific study of life. And at the end of the lecture, we hope to understand the steps involved in a scientific method, understand the nature and limitations of scientific observation and experimentation, know the operation and parts of scientific equipment like the microscope and spectrophotometer, and also identify variables and control of an experiment. The key elements of any scientific method include 1. Observation. It is important to make observation that stimulates you to ask yourself questions. Then you form testable hypotheses and make predictions. Then you conduct an experiment to help you test or evaluate the hypothesis. Based on your results, you either reject or accept the hypothesis and conclude. If results and conclusions are consistent across several experiments, then we can accept the hypothesis as a theory. A summary of the scientific method is what is drawn here. Make an observation, ask a question, form a hypothesis. Based on the results, you either you experiment, then based on the results, you either reject or accept the hypothesis as your conclusion. Let's take this example. We have observed that food exposed to the air become contaminated. The question is, might the contamination be due to the presence of microorganisms? Our hypothesis is that contamination of exposed onion will not occur due to the presence of microorganisms. Now, we need to conduct our experiments to accept or reject this hypothesis. So the experiment we have here is to store half onion wrapped tightly in a plastic wrap in a Ziploc bag in the fridge for up to 2 weeks, and then leave the other half in an open bowl. So from our results, we can see that exposed half onion develops black or soft spots, while the other half doesn't. In conclusion, we can reject the hypothesis and state that yes, contamination of exposed onion occur as a result of presence of microorganisms. The power of observation. Observation help us to invade into the unknown. Like we stated in the scientific method, observation, then you ask questions, then you draw out testable hypotheses to find out what is missing. So observation helps scientists to be able to invade into the unknown. And it is so much valuable and so much easy to follow through because it is not drawn from the new. You can observe or make observations from your present, past experiences, and learned activities or learned events, things that always occur around you. And this improves or enhances our ability to formulate accurate hypotheses and be able to make valid conclusions from the experiments we make. Limitations of scientific observation. In as much as scientists value a lot from making observation, it is important to note that not all events can be observed. Nature keeps changing, so it is very likely that there are some observations, there are some occurrences that might happen in my absence when I am not there to observe. So that is another limitation. And the other limitation is that it is sometimes difficult to analyze what we observe. It can be difficult to quantify, and it can even be difficult to measure. Generalization can be invalid, and this can also be due even to the bias from the observer. The microscope. It is a scientific tool or instrument that is used to observe magnified objects that enables scientists to be able to see small details of small or smaller details that couldn't be seen by the unaided eye. This is the microscope, and we would go through the parts of the microscope. So the first one, number one, indicated by number one, is referred to as the ocular lens or the eyepiece, and it is what the scientists see through to view the magnified specimen. We have the ocular tube, which is used in the microscope itself, but specifically to where the light passes from the objective to the eyepiece. So that is the medium through which light passes from the objective lens to the eyepiece. And this is the objective lens indicated by number 12. We would go there. So light passes from the objective lens to the eyepiece through the ocular tube. And 3, which is the arm, it holds in position the upper part of the microscope over the stage. We also have the slide clip, which holds the slide in place on the stage. We also have the control knobs, which provides both horizontal and vertical movements of the slide on the stage. We also have the coarse adjustment knob and the fine adjustment knob. So the coarse adjustment knob provides immense movement for initial focus, and the fine adjustment knob, as the name implied, provides a more refined movement for precise focus. The base provides the stand for the microscope, and when you are carrying or moving the microscope, it can also be used as a support to carry the microscope. So you hold onto the base and you grab the arm to move it around from one position to the other. And we also have the illuminator adjustment, which provides light beneath the condenser and the diaphragm. And it simply is a mirror intensity of light that is adjusted according to the thickness and the density of the specimen that is being focused. We have the condenser, which focuses and concentrates light on the specimen or the object of view. We have the objective lens, which is used to provide magnification. So magnification is calculated as the objective times the ocular lens. To the spectrophotometer. It is an instrument that is used to measure and relate concentrations of liquids. The more concentrated the sample under view, the more light it is able to absorb, and the less light will be able to pass through the sample. So absorbance is indirectly proportional to transmittance. Variables and controls. So a variable is simply defined as the factors that has the ability to change and influence the results in the experiment. The independent variable is the factor that the scientist change or has the ability to manipulate, and the dependent variable is the factor that we are measuring. It is what we are measuring in the experiment. Extraneous variables are variables that are not considered, that are not primarily considered in an experiment. However, it has the ability to affect the dependent variable. Another example, effects of different fertilizers on plant growth. We are experimenting the influence or the effects that different fertilizers have on plant growth. Now, the independent variable is the different fertilizers that we use. It is what the scientist has control over. It is what the scientist is able to manipulate. So the scientist has the ability to choose the fertilizers that he or she would use to observe the plant growth. And what we are measuring, which is a dependent variable, is our plant growth. So plant growth would be our dependent variable. And also because it depends on the type of fertilizer that the scientists use. Some extraneous variables can be sun exposure, temperature, amount of water, and others. Now, the control in the experiment removes the effect of the independent variable while keeping all other conditions the same. In conclusion, from what we have covered today, it is important to note some of the key elements of scientific method: observation, question, hypothesis, prediction, experiment, and conclusions. Observations help improve our ability to formulate accurate hypotheses, and scientific instruments give scientists the opportunity to amplify and extend their powers of observation. Scientific research can be sectioned into parts that are referred to as variables, where we would have our independent variable, dependent variable, controls, and extraneous variables. I hope you enjoyed the lecture. See you next time.